I will send when the class is over to YouTube, and you can watch it again if you want several times. Okay. Now, complex number. We are talking about complex numbers. It is a complex number you can find when you try to find square root of a negative number, no? And the reason is this is no real solution. Let me prove that. Why no? Why no? Why no, professor? Why no? Because the real number is a number that we can put inside this number line. And the definition of the square root is I need to find one number que multiply by itself. Give me the number inside the radical. So for example, good candidate, okay, I think is 5. 1, 2, 3, 4, and 5. 5 doesn't work because 5 multiplied by 5 is the same as 25. But I need negative 25. If you select negative 5, 1, 2, 3, 4, and 5, negative 5 multiplied by itself is 25 again, because I know that double negative is positive. So the conclusion is the solution of this square root negative number is not inside this line, and this line represents all real numbers. Okay? How the mathematician solving that problem? Well, the mathematician, by definition, create que square root negative 1 is symbolic I. It's called I in the whole world, in the whole mathematics, everyone understands that I is equal square root negative 1. And this allows me, when you face again that problem, well, you break it down like a square root positive 25 times a square root negative 1. And a square root positive 25 is 5, you know that. And this is I by definition. And then the answer is I. So in that moment, we have a new kind of number that's called imaginary. Imaginary number. Imaginary number. An imaginary number is a number que contain I. And the number that we use in every day in our life is a real number. It's a number que don't contain I. It's a new number que contain I. Okay? Okay, so now let's practice a little bit. One example. So, bueno, professor, what is the formula? What is the, they are formula? Yeah, they are formula. The formula is the formula. Look, the formula is formula. When you face square root negative any number, is equal I, and you compute the square root of this positive. Okay? Example 1, to understand this. Square root negative 200 is equal, wow, it's I, it's imaginary, because it's a quantity negative inside the square root. This is I times square root 200. 200, unfortunately, is not perfect square, but you break it down like a 2 and 100. And the square root 100, I know que es 10. The answer is 10I outside the radical. Radical 2 stay 2 inside the radical, and this is the answer. Again, imaginary number, because it's negative inside the radical. Super. Everyone follow me? Yes or no?
Yes.
Okay, now let's practice a little bit. Example 2. Example 2 is a combination, not only one. So, 2, 3, 4, 5. Suppose square root negative 9 times square root negative 9. Multiplication both of square root negative 9. So, the professor explained me that when you have a negative number inside the square root, the answer is imaginary. It's square root 9, que es 3. And this is exactly the same, 3. Hello, sir, I joined late. Okay. Entonces you multiply 3i times 3i es 3 times 3 que es 9 y I times I es I squared. Okay, so I take advantage of that moment to explain the I squared is equal to -1. It's unbelievable, but it's true. Okay, let me come back again to the definition. I alone is square root -1. If you square both sides in this statement, we have I squared, and you know very well the square root and square power cancel out each other, and the answer is -1. Therefore, look, I alone is imaginary, but I squared is not imaginary. I squared is real, it's -1. So the answer, you don't leave it like that. This is not incorrect, but it's, you know, it's not completed, the idea. So you replace I squared for -9, and the answer is -9. Boom. Do you understand very well this or no? Because I squared is -1. I high, by definition, is radical -1. And this is -1. Do you understand or no? Yes or no?
Yes.
Confusing? No, clear, right? Example 3. Okay, square root -64 times square root -25. Exactly the same. Remember the shortcut. You compute the square root of the number inside, the 64, I know gets A, and you put I, because the reason gets I is because it's -64. Si it's positive 64, it's just 8. Real. It's not real, it's imaginary. Likewise, this is 5i. A multiplication of 40, I squared. But I know very well that I squared is -1, and the answer, my beautiful, elegant, final answer is -40. Boom. End the story. Super clear? Okay, let's do one more 4 and 5 example, similar. But in this case, I have 3. Suppose example 4 is square root -16 times square root -4 times square root -49. It's similar. However, we have 3 radicals. And we compute separately, one by one. This, and this. This is 4i, because I know very well that square root 16 is 4. This is 2i, because I know very well that square root 4 is 2. And this is 7i, because I know very well that square root 49 is 7. And in every case, we have negative quantity inside the radical. Therefore, we expect I. Okay? And now multiplication, the number. 4 times 2 is 8, times 7 is 56. But you have I cubic because we have 1, 2, and 3i. So I have no idea. Who is I cubic. Well, the continuation. I is I. I square is -1. It's real. I cubic, I have no idea. Question mark. But I cubic, I can break it down like I squared times I to the 1 power, ¿no? Y I know que I to the 1 power es -1, entonces -1 times I, que es -I. Wow. Again. I cubic is imaginary, but it's -I. And this is totally alternating. I to the 4 power is real. So the even exponent produce a real number, and the odd exponent 1, 3, 5, 7 produce the imaginary number. I want to show you in detail in a few seconds. But what is my final answer? My final answer like that? No. My final answer is -56i. Because I know very well that I cubic is negative. End the story. Anyone follow me or no? It's obvious que the final answer, you can reduce it in lowest term. Ale is very, very picky with this idea. You put 56 IQ, the answer is correct. But Alex do not expect that answer. So you put 56 I cubic, Alex says this is incorrect because Alex is software. And in the test on paper, maybe I understand your mistake. To say no, I don't give it in this question the whole score. I decrease in something, but no zero. Alex no, Alex don't understand. Alex say no, zero, zero. Okay, example 5. Example 5 is similar, but in this case I put 4. Negative 36 times negative 81 times negative 16 times and negative 9. And we compute one by one separately. This is 6i, this is 9i, this is 4i, and this is 3i. And so you put in the calculator 6 times 9 times 4 times 3. Does Alex give me an example? Yeah. Guys, any particular, okay, focus it in the mathematics now, eh? Any problem with the Alex, you, okay. I suppose that you communicate with me every day by email. You say you're concerned, your question, please ask me by email. Now it's mathematics we are doing, right? The answer I put in the calculator. By the way, it's I to the 4 power. I highly recommend that you need to get, as soon as possible, one calculator. What kind? Scientific. I highly recommend cheaper. TI 30X. It's super cheaper in Walmart or in any store. It's $12 approximately. But this is important. Not super important now, but I promise that throughout the semester we need the calculator because we have to work with a special function, exponential logarithmic function, that is impossible computed by hand. Okay? So the calculator is mandatory. Every student have a calculator in this class. Let me finish this. This is the final answer? No. Why no? Because I to the 4 is I to the 4. I can break it down like I to the second and I to the second, no? Each I to the second I know very well que es negative 1. And negative 1 times negative 1 is positive 1. Wow, unbelievable. Look, I to the 4 is positive 1, is real. This is real. And this is real also. And this no. This and this are imaginary. Don't worry because I want to study what is the continuation of this table. So what is the final answer here? Well, I squared is 1. Therefore, the answer is just 648 because 1 is invisible multiplier. Super. No problema. Everyone follow me? Understandable? Okay. So what is the continuation? The continuation is now I want to study in detail every power of I. 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 Okay, we study a little bit. We study I, okay, by definition is radical negative 1. I squared is negative 1. I cubic is negative I. I4 is 1 positive 1. What is the continuation of this? To the 5th, to the 6th, to the 7th, to the 8th, and so on. To the 9, why no? 9, 10, 11, 12. One more. 13, 14, 15, and 16. And we discover the partner can represent this. Okay? For example, I to the 5th power, well, I break it down. It's I to the 4 times I to the 1. But I to the 4, I know que 1, this guy is 1, and 1 is invisible multiplier, and the answer is I. So look, this is I, exactly like this. And the part is repeated in the same, so this in the same row as I. Look, I. Now I to the 6 is exactly -1. 7 is negative I, it's imaginary. This is a WhatsApp group, no? It's important to create the WhatsApp group in your class because you can interchange information, no? It's important. And I to the A is 1, 12 is 1, and 16 is 1. Wow, I take advantage of this 5. Everything is multiple of, exact multiple of 4 is 1. Entonces, what is the formula, professor? To suppose que I put any power. In the test, I put I to the any power. Well, okay. Let me try to explain what is the rule. The rule is easy. The rule is, suppose que I want to do I to the 15. Que I know que es negative I, no? Look here. I know. However, suppose que I know, because I want to construct complete this long table. No. You take 15. Divided by 4. By hand. No calculate. It's 3. Because 3 times 4 is 12. Subtraction. And the remainder is 3. And you take the remainder part. Okay, let me explain what mean that 3 and what mean that 3. Okay, by coincidence it's the same. These 3 represent the group. Look, this is the group 0. This is the group 1. This is the group 2. And this is the group 3. This 3 is that 3. But I don't care this number. It's not important. The important number is this. Can they indicate us the row? The row. This is the row. Row 1. Row 2. Row 3. And row 4. But this is 3 is the row 3. That one. This indicates us, okay, que es negative I. However, no. I have no idea. You put here I cubic because this 3 is this 3. But I know very well my memory. By memory, I know very well these rows here. This group 0, sorry. Yeah, I know by memory that I cubic is negative. And this is my final answer. Okay, conclusion. I divide by 4. Do you understand why I divide by 4? Because this part is repeated 4 by 4. 4 by 4, the group 1, group 4, group 5, group 6 is 4 by 4 element items. Now you divide by 4. When you divide by 4, you take the remainder. You ignore completely the quotient. The quotient is not important. And you reduce the exponent from 15 to 3. But I know that I to the cubic power is negative I. And that's it. Let's practice several examples. Suppose I to the 18. Example to practice. I to the 18. I to the 20. And I to the 9. Okay, you divide 18 divided by 4. I suppose to get 4, no? 4 times 4, 16. Remainder 2. So this is equivalent to say I square. Yes, well, I know que es negative 1. Boom, final answer. Okay, 20. 20 divided by 4 is 5. 5 times 4 is 20. Remainder 0. This is equivalent to say I to the 0. It's obvious, que es 1. Okay, look. I never see before I to the 0, but any number or expression raised to the 0 power is 1. Always. You know that. And it's no coincidence que 20 lie in the row 4, que any guy in the row 4, the answer is 1. Because I know that any multiple of 4, any exact multiple of 4, for example, in the next group, we have I to the 20, is 1. I to the 24, is 1. I to the 28, is 1. Any exact multiple of 4 is positive 1. And this is no surprise that 20 is 1. No? And 9 divided by 4 is 2, is 8, remaining 1. This is I to the 1 power. I to the 9. You can see here, where, over there. Look at that. I to the 9. Super easy. Super easy. Everyone saw that or no? Or you are completely lost? Come on, participation. I want to see your face now. Okay, Roberto Alcalá. Juan Santana. Go ahead. Question. Are you clear? Confusing? Example. What do you want, Angelica? Another example? You want another example? Angelica? Okay. Don't worry because in few seconds, no minute, we continue studying that part. But I suppose it's enough to understand the basic idea, no? Now, after we study the negative exponent, it's a little bit different, and you see more examples. And remember, guys, my way is, I forgot to say that, we cover every material before the test. I dedicate one lecture to the review package. Okay, in your moment I will send, and the test is very, very similar. It's very, very hard that you fail the test. See, you are here every day, you know? So you are missing, I understand. But si you are with me every lecture, it's very, very weird that you failed. Diana Perez, Laria Pervais. I need to be familiar with the new student. Sultana. Gabriel. Okay. Laria, is correct the pronunciation of your name? Okay, no problema. Let's continue. Okay, let's continue. By the way, let me say something. The first test is easy. However, some people fail. Okay, this subject, MAC1105, is a famous subject in college and university because a lot of people fail. I don't know why. I am teaching this subject 3,000 times. Yeah, I know very well what is important thing you need to know. I go directly to the point. No blah blah blah. I try to guide you to the succeed. Okay. Entonces we study so far imaginary number. For example, 3i is imaginary. Number. And for example, 4 alone without I is a real number. Okay, we study every day in our life. And the combination both, suppose 4 plus 3i is a complex. It's a complex number is a combination of reals. So basically, you can see in any complex number, you see here a real part, and here the imaginary part. Okay? A complex number is the combination. So we study now several arithmetic operations using complex numbers. Addition, subtraction, multiplication, division, and one more important is the conjugate. Conjugate. What is that? Conjugate of the complex number. The symbolic way to indicate conjugate is like that. 4 plus 3i. And you put here the bar, que it's hot. This is called conjugate. Conjugate is exactly the same family. 4 minus. You change the sign of the imaginary part. The real part stays the same. It's 4, 4. But the imaginary part changes sign. Opposite sign. This is the idea for the conjugate. Can you see the application in a few seconds? Let's move on to addition. Addition. Addition is super easy. Addition, you add. Addition. You add two complex numbers. For example, you have a complex number 4 plus 3i again, plus another complex number gets 2 minus I. Well, you remove the parenthesis, 4 plus 3i plus 2 minus I. And we combine later. Real and real together is 6. Imaginary and imaginary together. 3 positive minus 1 is 2. Is plus 2i. Final answer. Addition is super easy. It's just remove the parentheses and combine later. And subtraction is similar. Subtraction, but a little bit different. A little bit. Suppose again the same number, 4 plus 3i, to illustrate the same idea, but are now subtraction. Well, you remove the parenthesis again, but be careful with the subtrahend part, because the subtrahend part change the sign completely. So when you remove the parenthesis and the minuend part stay the same. When the subtrahend part, no, because the interpretation this is like an invisible -1. And when you distribute it like that, change the sign. This is -2 plus I. Now ready to combine later. 4 minus 2 is 2. And 3i plus 1i is 4i. Boom. Final answer. Subtraction. Addition, subtraction. Easy. Multiplication. Multiplication is a little bit more complicated because you multiply, for example, 4 plus 3i again times, we're using the same number in the example. After change in the review. So what is the interpretation? The interpretation is that the complex number look like no, actually is a binomial. So it's a plus b or a minus b, binomial expression. And you foil, of course. You multiplication. 4 times 2 is 8. 4 times minus I is minus 4i. 3i times 2 is 6i. And the last case, negative 3i squared. Okay, I'll leave it like that, no? No. First of all, I can see I squared, never you leave it like that, because I know very well I squared is -1. So you replace I squared for -1. You have again a minus 4i plus 6i plus 3. Because double minus, so but actually it's -3 and this is -1. Double negative becomes positive. Okay, ready to combine later. 8 plus 3, 11. And negative 4i and positive 6i is 2i. Final answer. Multiplication. Complex number. Foil. You foil and be careful. Any term can contain I squared, you can convert to real, because I know actually it's real. And finally combine later. And this is my final answer. 11 plus 12. Okay, that's it. No, because we have another example of the multiplication that is very, very important, is when you multiply conjugate. Okay, suppose you multiply two complex numbers, but they are conjugate each other. 4 plus 3i again, and 4 minus 3i. Remember the idea for the conjugate. I repeat again, conjugate is the imaginary part, look at that, I explain here. Conjugate is the same family, It's the same complex number, same number, 4 and 3, but the imaginary part is 3. I put the opposite side. And now, when you multiply the conjugate complex number, you see surprise. Surprise. I have no idea. I have no idea. I applied the regular procedure. The regular procedure is FOIL. I FOIL again. 4 times 4, 16. 4 times minus 3i is minus 12i. 3i times 4 is positive 12. And finally, negative 9, because 3 times 3 is 9, negative 4i squared. Okay, surprise number 1. Always happen, que the imaginary part is cancelled. Therefore, when you multiply two complex numbers and they are conjugate, the answer is always real. We have no I anymore. No. However, surprise, a second surprise, 16, I know that I squared is negative 1, and negative 1, when you replace here, become like a positive 1, and this is 25. Wow, just where come from this 25? What is the shortcut to do super fast this multiplication? Well, you realize that they are conjugate. Y I know que that fact always happen. Okay, entonces now the shortcut to do in 1 second is multiplication. No FOIL, no FOIL. Well, you can FOIL, but no, it's first and last only. Because I know the inner and outer cancel out. Look at that, inner and outer. Entonces, you multiply 4 times 4, 16. 3i es 9, pero es 9 positive. Always positive, always positive. Professor, and what happened with this negative? No, this negative and I squared together become positive. It's always the same. If you want, I do in general, suppose in general. Suppose you have totally arbitrary complex number. A plus IB. A minus IB. And you perform multiplication using FOIL, because I have no idea this shortcut. A square minus ABI, because it's A times B and I. It doesn't matter the position of the I. Some people prefer putting the front, and others prefer in the last part. Doesn't matter. Entonces, again, it's AB, putting alphabetic, plus AB, I. And finally is minus I square B times B, gets B squared, right? Entonces always happen, always, I guarantee you 100%. This cancel out, the answer is real. And remember, I square is negative 1. When you replace here, negative double negative become positive, and my final answer is A squared plus B squared. Done. Real and multiplication first and last. First, last. First, last. And what happened with the negative? What happened with the I? I don't care. Don't change the answer. Let's practice a little bit. Let's practice multiplication for the conjugate. Gets a special important product. Okay, suppose this example. And you help me. Suppose you multiply 2 minus I times 2 plus I. Suppose you multiply 1 plus 3i times 1 minus 3i. Suppose you multiply, why not? 1 plus I times 1 minus I. Okay, this is the case in which they are conjugate, right? So when there's conjugate, you can apply shortcut. Some people say, well, professor, never memorize the shortcut. Okay. We can use it for, yes, we can. Either way. But the shortcut is fast, no? I suppose. Who helped me with the answer for the first one? Number 1, number 2, and number 3. Come on, participation. What is the answer for the first?
The answer for the first one is 5.
F5, very well, David. David said F5. Everyone is agree or disagree? Where come from this 5? 2 times 2, F4. 2 times 2, F4. And the coefficient here is 1, no? And 1 times 1 is 1. Pero professor, ¿es plus o es minus? Always plus. F5. Boom. Final answer. David, no more participation, okay? Allow another student to participate. What is the answer for the second? Another participation. Another participation. Come on, the new student. I want to know the knowledge of the new student. Oh no, the continuation student. Smart, I have que are super smart. Okay, la que Juan Santana, la que Angélica Jiménez, la que Yasmin. Edgar left. Edgar dice, no, I'm scared. I don't want to participate. Where's the answer? Where's the answer for the second? A María Covarrubia. María Covarrubia, you was my student, no? Before? No. I have another María Covarrubia, but no, maybe it's another.
No, it was my sister.
Okay. A ver, can you show me the problem again? No, of course I can show you the problem again. Do you see now? Do you see now? 1 plus 3i, multiplication 1 minus 3i. 3i. Do you see or no? Okay, I asked you what is the answer and the number 2. No, after number 3, no? Es 10. Very well, Angélica. Angélica say que number is 10. Where come from 10? Well, multiplication first and first. 1 times 1 is 1. Always plus. And 3 times 3 is 9. Boom, it's 10. Super. Okay, what about the last one? Another, no Angélica. No Angélica, no David. No. Another participation. Es 2. Very well, Ang Lang. Ang Lang saying it's 2. Because 1 times 1 is 1. And the coefficient here is 1 is 1 is 1 plus 1 is 2, coño. No do I. Okay, Lariap Pervais. No, okay. Listen to me. When you multiply two complex numbers and they are conjugate, the answer that we expect is always real. Never no I anymore. Okay? If you don't believe very well this, I want to prove one more time. Look, let's do it 1 plus I times 1 minus I. Suppose that I have no idea shortcut. Okay, no problema. Y hay 4. 1 times 1 is 1. 1 times minus I is minus I. I times 1 is plus I. And this is minus I squared. One more time, I verification que the I part is cancelled out. Do not exist. No I. And I know also que I square is negative 1. When you replace negative 1 here, double minus become positive. 1 plus 1 is 2. Real number, real. Okay. Keep in mind. Multiplication. 2 conjugate. No. Si es another family, no. Si es another family, look at that. This example is no conjugate. And this example, and the first one we are doing, that one. In this case, no conjugate. It's two completely different. 4 plus 3i times 2 minus i. No conjugate. But when it's conjugate, the answer that we expect is just real. Look, real. No I. Clear or confusing? Clear or confusing? Clear. Very well. And we take advantage this fact to perform division. We take advantage this fact to perform division. I want to explain division now. Division now. Look, suppose I am doing division. Division to complement. Division now. Division. Suppose you divide 4 plus 3i divided by 2 minus I. Oh, division. So what is the procedure? What is the systematic algorithm to do division? Always, anytime. Every student in the world doing it that way. Look, this is my original problem. I understand, original problem. This is original problem. I create now here. Look, I create the multiplication of the original problem by one thing. Okay, it's like a smart one. So what is the condition to create a smart one? Bueno. You create a smart one doing or taking the conjugate of the complex number and the denominator. And you know that when you have any expression divided by itself, and it's the same, it's 1. And this one is invisible, multiplied, and doesn't affect my original problem. So the blue part represents the smart one can help me to simplification the division. Okay? So immediately you have the original problem. You try to find the smart one. How you find the smart one? You take the conjugate of the complex number and the denominator, not in the numerator, no, in the bottom, and you multiply and divide by is. So I know okay, when you multiply, well, you multiply top, bottom. It's the rule of the multiplication and the fraction, no? But when you multiply the bottom part, it's special. And it's a 2 times 2, okay, 4, and 1 times 1, is 5. The answer is 5. So we did before, no? This example. I create intentionally to understand this, waiting for that moment. Now, in the top, no. In the top, it's no family, it's no conjugate. To say you try to do using regular FOIL. 4 times 2 is 8. 4 times I, 4i. 3i times 2 is 6i. And 3i times I is 3i squared. So far, everyone follow me? So the thing in the bottom was easy. Shortcut. Now, I apply one more time, always in the multiplication, the regular multiplication. I know that I square is -1. Therefore, we have 8 plus 4i plus 6i, and you have -3 here, actually. Sorry, -3. Because you replace I squared for -1. And -1 and positive in the front become negative. And leave it like that? No, of course, no. We combine later. Entonces is 8, the real part, and -3 is positive 5. Okay. Plus and 4i and 6i together is 10i divided by 5. And leave it like that? No. Why no? Because I never see before in my life a complex number you can write using common denominator. No. The standard, look at the standard. The standard is standard M for to express any complex number is A plus IB. This is a number, no? So you split that common denominator like that. 5 divided by 5 and 10i divided by 5. And 5 divided by 5 is 1. And 10 divided by 5 is 2. And this is my beautiful final answer. Any question? Division of the complex number. Let me summarize, recap. When you perform division, you create a smart one. smart one is formed by the conjugate of the complex number in the denominator of the original expression. Now multiplication, top, bottom, bottom. Pero bottom is special. And you apply the shortcut. Multiply 2 times 2, 4. 1 times 1 is 1. And plus always. 4 plus 1 is 5. Only one real number. I take advantage this 5. This is just real. No I anymore. And the top no. And the top no, because normally no family is completely different. And you apply regular FOIL. We combine like term. Don't forget, replace I squared for -1 because I squared is real. And the rest is split the common denominator because I need to express like that, standard. Look, si I copy that 1 plus 2i. Es obvio que A es 1 in this example and B is 2. Doesn't matter. It doesn't matter the position that you put. Some people prefer 1 plus I2, but I don't like this. I don't understand very well this. Okay? When it's a variable, when it's a letter, maybe yes. But when it's a numerical, no. Okay? Do you get the idea? Do you get the idea? Division? I have 2 more examples. No? I have 2 more examples. But it's okay. I stop here to ask you. Do you understand the basic idea for the division? Procedure? Aha! Okay, let's move on to another example. In that case, easy. Look, in that case, a real number divided by a complex number. Okay, this is my original problem. Immediately I create the smart one. Okay, always is a conjugate of the complex number in the denominator. So I put here totally artificially that part. When you multiply the top part, the bottom part, sorry, I know que es special, and the answer is 10. We did before, right? 1 times 1 is 1, 3 times 3 is 9, and always plus. Don't be scared if you see negative. No, this negative disappear. I prove you. Now, and the top part is easy because it's no FOIL. It's distributive property because 10 is a monomial expression. 10 times 1 is 10. And 10 times 3 is 30. All right. I leave it like that? No, of course. You split this common denominator. 10 over 10 minus 30i over 10. 10 over 10 is 1. And 30 divided by 10 is 3. And the answer is 1 minus 3. 1 minus 3. 3. Any question? Clear or confusing? Our class confused. Okay, what part is confusing, Laria? The where come from that thing? Do you want it? All of it. You are pessimistic, no? Okay. We are here to learn. Is there any question that you have? You let me know. Can you do one more? Yeah, I can. Of course I can. But this is the extremely easy example. Maybe the confusing part, I suppose, Laria, is the que you don't get the multiplication, this multiplication, no? Pero okay. So you won't be able to memorize the shortcut, no problema. You apply FOIL again. Okay, let me prove that this is 10. Okay, put directly here. 1 times 1 is 1. 1. 10 is right. Well, si 10 is right, what part is wrong for you? What part is wrong for you? One of the, look, in the top part, it's easy because it's 10 multiplication 1 minus 3i. Entonces, you apply distributive property, es 10 minus 30i. And so you understand very well que this is 10. Well, actually, look, we can simplification this and this. Bang! And we get, oh. You split this 10 here. And we get exactly the same. Yes. More clear now? Beautiful. One more example for you, Laria. One more example. No problem. I'm here for help student. Okay. Suppose this. Could you guide me? What is the step? Could you guide me a little bit? What should I do? Suppose I am confusing.
Okay, what you is make a smart equation with 6 plus 9i.
Exactly. You say Laria is multiply top and bottom by 6 plus 9. Excellent. Suppose now I have no idea. Well, I multiplication top, bottom, no? So let's do in the top part. I like put the bottom first, but it's okay. You multiply this and this. It's a foil. We are doing foil. It's 48. This and that is 72, no? 72i positive. Because we have I here. This and this 54. 54, no, 24. I, 6 times 4. And the last one is 36. Positive. I squared. In this moment, some people prefer automatically, because I know that fact, I squared -1. Some students prefer, including me, prefer doing that way. No I squared anymore, and you change the sign by negative. Do you like this way, or let's do it step by step? What do you consider is better?
Step by step.
Okay, let's do it step by step. Okay, no problem. Understand. Okay, no problem. Step by step. Okay. Look at that. Boom. So in this moment, I copied up 48 plus 72i plus 24i. Yeah, I know that fact. I squared -36. Boom. Keep going. Of course, we keep going. We combine lighter. Who is lighter? This and this is lighter. Boom and boom. Real is 12, no? It's 12 because 48, you put in the calculator, guys, 12. Plus something. And the imaginary part is this and this. Case 96, no? 96. Okay. 96. Can somehow add Okay. I did that. The top part is 12 plus 96i. The bottom part, I don't know if you want to apply shortcut or no. Shortcut or no? Or no shortcut? What do you consider better? Shortcut or no shortcut? Opinion. Because no shortcut means no shortcut. Okay? I respect. No shortcut. She prefer doing foil again. Okay, let's do it. So you multiply 6 times 6, 36. 6 times 9i, 54. Negative 9 I times 6 and negative 54. Do you see how the imaginary part is cancelled out? And finally, we have negative 9 is 81 I squared. Yeah, so it always happen. I guarantee you 100%. That is the reason that I recommend shortcut, because you avoid this stupid situation. Because I know this fact. So when you multiply any complex number that is conjugate, the answer is real. So the imaginary part disappear. Definitely. And we have 36. And again, we have negative 81, but I squared negative 1. Entonces el doble negative become positive. Entonces es 100, es 11, es 170. 170. So far we have in my paper 12 plus 96i over 117. Well, to say you can, yeah, we can split 12 over 117 plus 96i 170. Es obvio que 117 and 12, so we can reduce this fraction in lowest term. 117 is divisible by 3. And 12 is divisible by 3. We can reduce. This is 4 over 39. And basically, the thing I did was divided by 3, is 4, and divided by 3, is 39. Likewise, 96 is divisible by 3 also, is 32. And divisible by 3 is 39. So the answer is 32 over 39. It's important, guys, that in your final answer you have to mandatory reduce any expression in lowest terms. You putting Alex like that, Alex considered wrong. The actual is not wrong, but this is not elegant. So my final answer is always reduce it in lowest terms. Any question now about division? Any question now about division? No question. Wow, good. Okay. 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 Okay, entonces el área, everything okay for you? Answer me. Yes, sir. Okay. Okay, so now, as I promised before, we go now to another topic. It's the power of I, pero using negative exponent. Because I don't know. I guarantee you guys, in the test, you can find one problem in which you have I to the any power. But in this case, we study when you have positive exponent. It's what happens when there's negative exponent. This is the new topic. Power of I with negative exponent. It's a power of I with negative exponent. Okay. Okay. Then, entonces, let me ask you by curiosity. Do you remember what means negative exponent? Do you remember what means in algebra, negative exponent? Suppose you have 2 to the negative 2. What the hell is that? Negative exponent. Es reciprocal. Es 1 over 2 to the second power. Reciprocal. 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 Reciprocal means flip it, no? It's exactly the same here. It's 1 over I to the 9. And that's it. No, of course no. Because first of all, you need to solve the exponent positive now. So This idea, the reciprocal, allow me change negative exponent to positive exponent. But I face the problem of the positive exponent. You know, 9 divided by 4, remember, always divided by 4. Because I proved here que the partner of the I power is 4 by 4. Therefore, you divide by 4 always. Entonces es 2, ¿no? Es 8 and remainder es 1. Okay, I take the remainder. I know que I to the 9 is equal I, is equivalent. 1 over I. And that's it, professor. No, of course no. Because you are doing now division. You divide 1, que is a real number, divided by I, que is imaginary number. And you are doing exactly the same procedure of the division. Okay? Procedure division. Okay? And the procedure division, the professor explained me, que es the conjugate. Okay, so we are doing by the conjugate. This is my original problem. Look at that. 1 over I. And what is the conjugate of I? I'm confusing. Because I know very well how you find the conjugate of the arbitrary complex number. The conjugate is 2 minus 3i because it's easy. It's only change the sign of the imaginary part and the real part stay the same. But in this case, I alone is interpreted like 0 plus 1i. Because I alone have no real part. It's pure imaginary number. Entonces es 0 minus 1i. So you change the sign. The actual is negative i. So the conjugate of I is negative I. Makes sense or no? Makes sense or no? Then you create this smart 1 minus I minus I. And you multiplication. 1 times negative I is negative. And I times negative I is negative I squared. Yes or no? But I know que I squared alone is negative 1. So you have negative I divided by negative 1. You replace I squared by negative 1. Double negative becomes positive. Positive 1. And you know que 1 positive is totally invisible. Divided by 1 or multiplied by 1 is do nothing. And the answer is negative. The answer I need. Any question? Any question? Any question? Any question? No, no question. Good. I like that. Let's practice a little bit. 2 more problems. Okay. Suppose that I have I raised to the negative 13 power. What should I do first? What should I do first? What is the first operation you should do to face that problem? Come on, come on, come on. I like that class because that class is a combination of the continuation students plus new students that I know they have good participation. Okay? So what should I do to face that problem? No idea? You are lost? Aha! You put 1 over reciprocal. Okay. Now I have now 13 positive. Yeah, I know very well how you are doing that. It's 13 divided by 4. Always divided by 4 is 3. It's 12 and the remainder is 1. If I take this remainder here, so I know que I to the 13 is equal to I to the 1 power, que es invisible, it's just I. Okay, ready to continue. Division problem. Never live like that. This is completely wrong. Well, not wrong, but it's incomplete. Because remember the standard. Divided by 4. No, by 4. Divided by, okay, divided by, so you create the smart 1, no? The smart 1. what is the conjugate of I? Es negative I, no? Yes or no? Yes or no? You follow me or no? Okay. Yes, okay. Roberto. Alkalize, yes. Then, okay, in the top we have negative I. In the bottom we have negative I squared. But I know que I squared is -1. Negative 1. Double negative become positive. And you know que it's invisible divided by 1. And the answer is negative. Again, repetition, the same as 1. Remember, we have only possibility, positive I, negative I, 1 or 0. It's the power of I. 1 or -1, sorry. So we have potential for value. O es I, o es -1, o es negative I, o es positive 1. Another answer, suppose 2, no, it's impossible. And the power of I, of course. One more example. I to the negative 11. I to the negative 11. Let's do it quickly because you know the procedure. You convert to positive. Apply the idea for the reciprocal. Flip it. Now, you take 11 divided by 4. It's 2, I guess so. It's 8 and remainder 3. I take the remainder. I know that I to the 11 is equivalent to I to the cubic power. Yeah, I know okay, this is negative I. Actually, I put here 1 over negative I. And leave it like that. No. Now I need to perform division. What's the conjugate negative I? Positive I. In the top we have I. In the bottom, I did this product. I did 3 times. Okay, I know the 1. The answer is that. I. Just so. Boom. Final answer. Any question? Any question? Any question? Any question? We are the best in Miami-Dade College. Yes or no? Yes or no? Okay. Of course, yes, but no now. In your moment, Laria, in your moment, remember we have time. We have time in the review. I bring a lot of problems and we start at the beginning. We go over again to this. But today, no, we continue another thing. Okay. Either way, you want, I create one for you. Suppose, compute I to the -12. I create that. Pero, could you help me, Laria? What should I do first? You using the chat or activate the microphone? Either way. Divide, no, divide is the last part. Reciprocal, no? You try to say reciprocal, no? Reciprocal. Okay. 1 over I to the positive 12. After that. Yes. After that. 12. Divided by what? By 4. 3. 3 times 4 is 12. Wow. Remainder is 0. So actually, I know que I to the 12 is equal to I to the 0, que es 1. Entonces, 1 over 1. Wow, it's a real. Si es real, it's easy because it's just 1. Boom. Final answer. Any question? Okay. For the class is over. No problem. No? No what? Claria. Do you want to do another? No question. Okay, super. Thank you. Okay, now let's move on to the, well, this is exactly the same. This is the power. Remember, we are studying any operation, arithmetic operation with the complement. We are studying addition, subtraction, multiplication, division, power of I with the positive and negative number. And now we are doing power of any complement number. I bring 2 examples. Suppose the first example is 2 plus 3i raised to the second power. Well, to the second power is easy. Si es to the cubic power is more, not complicated, but it's too long. So you break it down like that. 2 plus 3i times itself. In this case, is twin brothers. Two twins, brother. It's not the same of conjugate. Conjugate is a family, pero no twins. Es like a brother and sister, ¿no? Ajá. Entonces, en the shortcut of the conjugate is not applied here. No. You apply 4. Yeah, that's it. 2 times 2 is 4. 2 times 3i, 6i. 6i again. And 9i squared. Okay. All right. Entonces, in this case, happens completely different idea for the conjugate. In the conjugate, you see that this is cancel out. The reason is clear because the conjugate have completely opposite sign. Well, completely no in the imaginary part. But in this case, it's the same because they are twin brothers. So you duplicate. Okay? So now the next step is replace, as always we are doing, I squared for -1, es negative 9, sorry, equal to -9. And ready to combine like term. This and this together is -5. And this and this together is 12. Boom, finalize. Good or not good? One more example, and that's it for today. Remember, our lecture is 9:40. Guys, 3 days per week, Monday, Wednesday, and Friday. Okay, I know it's exhausting, it's too long. Sorry, it's not my fault. I try to do my best, and you try to do your best also, right? Suppose this, okay, a little bit put weird using irrational number. But don't worry, it's the same idea. Okay, let me try it. So the first is you break it down into, in this case, twin brothers. Radical 2 over 2, radical 2 over 2, radical 2 over 2i, and radical 2 over 2i. They are plus both. Entonces you see, look at the multiplication, es radical 2 over 2 times radical 2 over 2. Entonces, go again, this looks like complicated. I try to put it separately here, like auxiliary calculation. Suppose que I multiply radical 2 over 2 over radical 2 over 2. To multiply top, bottom, so radical 2 over 2 times radical 2 over 2 is equivalent to, say, radical 4, no? And radical 4 is equivalent to, say, 2. I know that. I know that square root any number times square root the same number as any without square root. So radical 2 times radical 2 is expecting is 2. And 2 times 2 is 4. And leave it like that and lowest term 1/2. So any multiplication in this case is 1/2. When you multiply this and this is 1/2. When you multiply this and this is also 1/2, pero I. When you multiply this and this, it's also 1/2 I. And when you multiply the last, is 1/2 I squared. Because radical 2 over 2 times radical 2 over 2, I prove here in that part que es equal 1/2. So everything is 1/2, 1/2, 1/2, except the second and the third, que es I, contain I, and the last one, que es I squared. Pero I squared, I know que es -1. Entonces I replace 1/2 plus 1/2 I plus another 1/2 I minus 1/2, because one more time I repeat, I squared is -1. Wow, wow, wow. Look at that. 1/2 positive and negative 1/2 positive is cancelled out. In this case, the guy is gone, is the real part is gone. And the imaginary part, no, stay because 1/2 plus 1/2 is 1. I. Wow. Entonces, the answer is just I. Unbelievable. The answer of this problem is only one. It's one I. It's just I. Okay. Okay, guys. Okay, listen to me. Important thing before to finish everything. Okay, I want to stop sharing any screen. I suppose you see my face now, no? You see my face? Yes. Look at that. What is the thing that you should do now? Go to Alex and enroll in the course and start doing the homework. This is your job, okay? This is your job now. My job now is create the video of this lecture. Okay, by the way, I stopped recording now